Hey everybody, Sebastian Maniak here. So let's just jump in. Today I'm going to show you a quick demo and how you can get started with a new feature inside of Kagent open source called Human in the Loop. So let's jump in. So first thing, if you go to kagent.dev, what you're going to notice is on the blog site, I have a blog about this, and it's about this new feature. If you go into our docs and Kagent, under examples, you will see tons of other examples to deploy, but you'll see human in the loop. And what human in the loop allows you to do is straightforward. AI agents that can take, well, AI agents that can take actions are powerful, right? But you don't always want them to act without you saying so. So this tutorial that I'm going to walk you through builds a Kubernetes native AI agent that pauses and asks for your approval before doing anything disruptive, which is pretty cool. Because AI agents are getting good. They're getting really good, right? And they are taking that autonomous, or they're taking autonomous actions on behalf of themselves right now. They can inspect your environment, they can diagnose problems, they can create resources, they can even clean up after themselves. But here's kind of the uncomfortable question that we keep on seeing is that most teams are still asking. They're asking, I actually don't want my AI agent deleting things in my production cluster without asking me first, right? That's a big question everybody's asking. And the answer is almost universally is no, nobody wants it to do stuff, right? This is where this human in the loop comes in. And it's a pattern that lets you give an AI agent real tools and real capabilities while keeping the human in the decision loop for anything that matters, right? For those disruptive and important things. So what I'm going to do is we're going to build a cluster inside Kind here, and we're going to do some scenarios and set this up inside Kagent. And just to note, Kagent itself is an open source project for building Kubernetes AI agents, right? So let's dive in. Well, first, actually, let's set the problem, right? Or the scale or the scene, right? You build an AI agent that can manage Kubernetes resources, right? You give it tools, you can make it list pods, apply manifests, delete deployments, and it works great in a demo, right? Then someone on your team asks it to clean up an old staging resource, and it starts deleting the wrong namespace, or it starts misinterpreting things and scales down a database and sets replicas to 0 on your production Postgres stateful set. And we've seen this. You've seen this all over Reddit. You've seen this happen itself. And the issue isn't that the agent is dumb, is that there's no checkpoints between the agent that decided to do something and getting things done and the thing that got done, right? There's no moment where a human could look at the plan and say, wait, not that itself. And maybe we do have agents, right? Full autonomous agents that are fine for read-only operations, right? But for anything that has a change state, right? Maybe you want a gate to hold that. And this is kind of where this human in the loop takes place. And the feature inside Kagent is really designed with a few distinct mechanisms. We have the tool approval and the ask user. The tool approval is that the agent decides to call a tool, like deleting a resource, but instead executing immediately, the system pauses and represents an action to a human. And that human reviews it with either an approval or a rejection. And if we reject it, the agent receives the rejection with an optional reason, right? We can tell it why it was rejected. And then it adapts in its approach itself. And then the second mechanism is this ask user. Sometimes the agent doesn't need your approval. It just needs information, right? The request is ambiguous, or there are multiple valid paths, and the agent just needs you to make a choice, right? For example, which namespace should I create this in? Do you want to use Postgres or MySQL? Should I apply this to staging or production? Right? The ask user tool lets that agent pause the execution and ask a question and wait for your answer before continuing. And it's not a safe gate, it's really a collaboration mechanism itself. Then, of course, you can combine these, right? And the real power is using both mechanisms together, right? You can read your cluster freely. You can ask for clarification when the request is vague, right? You can accept your rejections gracefully and try different approaches. And that's an agent that you can actually put in front of a team and have somebody else use itself. So let's go ahead and open up the terminal and deploy the actual platform. So first thing we're going to do, let's share our screen. All right. So let me make this bigger. Just a little bit. There we go. Perfect. So inside the tutorial, it's pretty straightforward. The first thing we're going to do is we're going to use Kind to create a Kubernetes cluster inside our environment. So I'm just going to create a Kubernetes cluster so we can test this feature out. Once we have that, we're going to install the Helm CRDs and install Kagent. So for prerequisite perspective, you just need to make sure you have Docker, Kind, kubectl, and Helm installed. And for the demo or the tutorial I'm doing, you need to make sure you have OpenAI. I'm using OpenAI, but if you have Anthropic or Grok or XAI or something else, you can use that too. So now that the cluster is built, or the Kind cluster is built, we're going to install the CRDs. I already have my OpenAI key exported, but if you execute the following command and paste in your key, that's going to be inside your environment variables to use. Next thing we're doing is going to install Kagent. So as Kagent installs, what we want to do is let's take a look at the actual config that I have here. So I have a YAML file. This is really a declarative way of building agents. And I'll show this. You can edit this and create this in the UI or in the CLI, but it's a very simple way. We're using a declarative approach where we're building a Kubernetes agent, providing you a description. We're selecting the specific model. So in this case, by default, I'm just using OpenAI. If you have other LLMs, you can apply this to here. We're giving it a system message. You are a Kubernetes management agent, right? You help users inspect and manage resources in a cluster. Before making any changes, explain what to do, and if the user request is ambiguous, use the Ask User tool to clarify the request. So within that, what we do have is the actual tools that we're going to be using. We're using an MCP server. We're giving a tools list. So we got some Kubernetes tools, get resources, describe, apply manifest. And then we have this require approval section in here. And when you define an agent, you list the tools it can use. And for any tool that should require a human approval, you add it to the require approval list. Pretty straightforward. And that's it, right? 2 lines to add really a safety gate. The tools in the required approval must also appear in the tool's name. So the CRD, right, validates this at creation. So you can then, so you can't accidentally gate the tool that isn't assigned to the agent. And then every time the agent automatically has access to Ask User, right, you don't need to configure it. It's built in. So when the agent encounters an ambiguous request, it can just call it, pause, and ask the question. And the question can be free text, right? The user can type their answer. It could be a single select. So the user picks from the list of choices, or multi-select. The user picks from multiple options itself. And what's nice is that the user gets back a structured data, not just a raw string, which kind of makes it easier to act and to answer itself. All right, so now we have our environment. So let's build this up. So I'm just going to do just clear kubectl. We'll just do create. Pods. So we got everything is up and running. It's almost there. So what we're going to do, because we have this set up, we're going to log into the UI. So I'm going to just do a port forward on port 8080 so I can access the UI for myself. So let's go to our browser, localhost 8080. Perfect. We are logged in. Let me just make this a little bit bigger. When you first deploy Kagent, you're going to notice this wizard that allows you to set things up, prepare your models, set up an agent, or whatever you want to do. We're just going to skip on wizard. And also by default, you get a lot of agents already installed. But we're going to play with the agent that I just installed, the human in the loop agent. We're going to click on this, and what you're going to see right here is your chat history on the left-hand side and all the tools and agents that are part of this agent deployment. Then you'll also notice that there are required approval before execution for specific tools. So if we ask the questions and those tools get invoked, we're going to get some type of approval required or something will be asked. You can definitely edit this or create a new agent. We did this in a declarative way, but you have the capability of building the agent inside the UI, selecting the models that you want to use, enabling the tools through a drag and drop method, enabling even memory, context management, and applying specific skills. And we'll do skills another time in another video for you. So let's go back into the client and let's test this human in the loop out. So scenario one, let's do this. We're just going to ask, hey, list all the pods in the namespace. Let's go list all the pods in the namespace. And we can remove this so we can kind of see more of the screen. Perfect, right? The agent calls the get Kubernetes resource, right? Since the tool is not a required approval tool, it runs immediately. And we see the results with no interruption, gives us a list of all the pods inside here. Okay. So there's nothing to click approval, no information needed. So let's continue. Let's go scenario two, right? Let's create a configuration and test the config in a specific namespace and see what we get, because it should really go invoke the apply manifest tool. So let's create a config map called test config. Just do default namespace with the key message set to hello from Kagent. Perfect. So now the agent calls that apply manifest, and since the tool is in the required approval execution, right, we get a pause in the UI, as we can see here. The tool and the agent, the agent wants to call, and the argument it wants to pass. So we have the argument in YAML in the full manifest. So we can approve or reject this itself. So we're going to click on approve, and the agent applies this config map. Pretty straightforward. So scenario three is rejection with a reason. So this time, let's delete that config map in the namespace. And we're going to call the delete resource tool, right? So once again, this has been called, and then it's asking us, but this time, well, really what's asking, let's see, you want to delete the config map, you have requested to delete it. This is a destructive operation. Please confirm that you want to proceed with deleting this. So let's go, yeah, of course I do. Yes, actually, this time let's go, no, I don't want to. Yeah, yes, I want to do it. So now it's giving me the argument again. It's saying, okay, here is what you asked to do. You asked to delete it. So the agent received that rejection, or well, the agent hasn't received it, but we're going to send it right now. So what we're going to do is instead of approving this, we're actually going to reject it and then give it a reason, because this is important for it to learn. So we're going to reject it with a reason. So the agent now receives our rejection with a reason, and instead of failing or retrying, it acknowledges our decision and response, right? It understands, and it'll leave the config map in place, so we don't have to change it. And this kind of this key detail, right? It's small, but the rejection reason isn't just logged, it's sent back to the LLM as context. So the agent can now adapt its behavior based on why you said no. So the final scenario, let's ask for clarification. Sometimes when we're setting things up and we type things, vibe code things a little bit too quickly, we forget to give it stuff. So let's say, hey, let's just set up a new namespace for my application. Right. So the agent doesn't know what to call the namespace. So instead of guessing, it invokes the ask user. Well, what should the namespace be called? So let's go staging environment. Then the agent continues, creating the namespace with what I specified. And it asks me, hey, do you want to approve or reject this? So let's approve it. And done. Now we have that namespace. Now we go, can you list all my namespaces? And boom, there's my namespaces and my staging environment that was built. The difference between an agent that guesses wrong and an agent that gets it right is the cost of really asking only a few seconds, right? The cost of guessing wrong in rolling back a mistake, right? That's a massive cost, right? If I have an error, if I accidentally deleted something, I pressed it too fast, I didn't understand what was happening, I deleted a cert, I deleted a resource, it only takes a second to ask, but to roll back might take long. So really when creating or when implementing kind of this human in the loop, we want to kind of follow some design principles, I find. And things that are worthy are opt in and what to opt out, right? Tools can run freely by default, right? You explicitly list which ones you need approval. This means you can add, new read-only tools to an agent that doesn't require updating any approvals, right? Those things work. Having a declarative agent, not this procedural, right? A declarative agent, right? You don't write the approval logic in code, right? We don't do that. We don't want to do that. You can add a tool name to a YAML list, and this keeps the agent definition readable, right? And audible. The security reviewer can look at the agent YAML file and immediately see what tool requires human approval. And then also rejection in context, right? When you reject a tool call, you can provide a reason. And that reason is returned to the LLM as part of the conversation context. And this means that the agent can learn from your rejections in the current conversation and adjust its approach. And then 4 is that always available, right? Ask user is always available. You don't need to confirm ask user. It's built into every agent. And this encourages that the agent builders, or it encourages that agent builders to write system prompts that tell the agent to ask when things are ambiguous rather than making assumptions itself. So to clean up this lab, once you have it kind of deployed, it's pretty simple. Just do kind delete on the cluster itself. Hope you enjoyed this quick tutorial on human in the loop. It's just the latest feature on Kagent, on the open source Kagent website. I'll kind of post the website here and show you some links. Definitely check out the blog. And hopefully you enjoyed this kind of quick tutorial on getting a human in the loop running with Kagent. So definitely feel free to kind of like and subscribe. And thank you for joining.